Welcome to this new session. What we're going to talk about today is an introduction to the Python programming language. So the first question you might be asking yourself is, why do I need to access a database from a programming language? And really there's a lot of reasons why you might want to do that. The first is that you just want to automate those queries. You don't want to create every single query that you have to a database by hand. And that's especially true when you're running a database on a web server where it needs to, your client may be asking for different queries, such as they want to have different statistics or visualizations of data. And to do that, you're going to want a programming language to interpret those queries and give them to the database. More and more, you see remote devices that are inserting and querying data from your database. And that's going to require that you do this with a programming language. And finally, you want to do this from a programming language because eventually that programming language is going to be able to run statistics and predictive models. And it's faster to load data from a database than it is to load it from a file. And that's the biggest advantage that we have for databases. And why using Python? Well, if you look online, you'll see that Python is a very easy to, and expandable language that you're going to come to either love or hate. And most of you will learn to love it. In fact, as a data scientist, if you look at the top 3 programming languages that you need to know to interpret data, you're going to see that R, SAS, and Python are used almost exclusively by most of the data scientists out there. So Python, a little bit of a history. Python was created by a man named Guido van Rossum, who worked over at Google. He's now over at Dropbox. And if you go and look at the biography of Guido van Rossum, what you're going to see is that he created Python in 1989 as kind of a side hobby programming project while he was taking a break from Google. This was around the Christmas time era. And you'll come up with a few takeaways from the Python language. The first is that it's an interpreter, right? Python is something that gets interpreted at the bytecode level. So it's not necessarily as slow as some other interpreted languages like MATLAB, which are interpreted more at the text-based level. It's a scripting language. So like some of the programming language, I can open up a terminal and actually write code in Python, have it be interpreted on that line and spit out the result. I can also write different scripts in a .py file and run those like I would from a normal programming language. It was also created and designed really for hackers. And that means it's got a lot of quirky things to it. It can be used in a lot of different scenarios. And just because it was created for hackers, don't let that fool yourself into thinking that this isn't a programming language that's very serious, because it is. And finally, Python was named after Monty Python, specifically the Flying Circus. And so when you see Python examples online, you're going to see things that instead of using variable names like foo and bar, which you might actually see in Java language, you're going to see things that say like knights and knee. It's a very interesting and kind of quirky style for Python. A couple of disclaimers. When you download Python, its model that it uses is batteries included. That means that everything that you need to run the different scripts that you have from Python are already installed on your laptop. And if you want to use libraries that have been created and are specialized that don't come with the whole Python base, it's going to be very easy to install those libraries and get those up and running. Python uses weakly typed variables. And that means that you don't have to declare variables, and that the variables that you have can change types dynamically. So one moment they might be an int, and then you save a float to them, and then the next moment you save a string or a complex object to them, and that's fine to do in Python. Again, Python is an interpreter, so loops can be slow, but again, not as slow as other interpreted languages, because Python is interpreted at the bytecode level, which makes it kind of an interpreted language, kind of a compiled language. Errors are mostly going to occur at runtime, right? Because it's not compiled, a lot of the errors that might Java or C are not going to be caught by Python. You can't use parallel instructions natively. However, we are going to download a library called IPython and use that to run a little bit of parallel programming. Python is also great for being a glue for tackling different code bases that are written in different languages like R and Java and C, because Python can be used as a wrapper around all of those different programming languages, which makes it really, really useful. Python has 3 different releases, 1.0, 2, and 3. Starting with Python 2.0, it became a completely object-oriented programming language, and that was great. And there were a lot of paradigms that were created. Some of those paradigms meant that you could do things a lot of different ways in Python 2.0, and they wanted to eliminate that so there was only one kind of correct way, and that's why they created Python 3.0. The problem was when they created Python 3.0 that it wasn't backwards compatible with Python 2.0, and so both 2.0 and 3.0 are actively developed today. We're going to use Python 2.0 in this course because it's just a little more stable, and there's a lot more examples out there in code bases for Python 2.0. So why should you learn and know Python for your career? Well, there's a few different reasons. If you look on any of the top 10 programming lists that are out there on the internet, you're going to find Python that is either in the top 5 or maybe even number 1. For Hacker News, it's been number 1 for quite a few years now. In Dice's job list, it sits at number 8. And in book sales, Python, the number of book sales that you'll see for a programming language, it actually ranks number 8 among all different programming languages. But maybe something that is a little more telling is to graph out the number of tags that you see with Python in Stack Overflow versus the number of GitHub projects, right? The number of projects that you see that people are working on that are written in Python. And if you look at it, what you're going to see is that Python is consistently ranked in the very top right of that graph, right? Along with C++, Java, JavaScript, and Ruby. So you probably should know it. For installing Python, if you are a Mac or a Linux user, all you need to do is open a terminal. Python ships with OS X and Linux. If you're on Windows, you can go to python.org and get it installed on your system. And I trust that you'll be able to do that on your own. You'll also want access to different Python packages. And the way that you'll do that is by installing something called Macports or pip or Homebrew. Pip is something that I've had a lot of good luck with, even on the Mac install system. And this is going to allow you to say something like pip install and then the package name. So if it was NumPy, it would be pip install NumPy, and you could download that onto your system. So now let's go ahead and do a live demonstration. So if you want to run Python, what I'm going to do here is I'm just going to open up a terminal. Here we go. And now what I'm going to do is, the first thing I'll do is to launch Python from the console here, I can just type Python like this. And now I've actually got a Python instance, and this is Python 2.7 right here. So if I want to do a hello world function, the only thing that I need to do is say print hello world in single quotes, enter, and there's my hello world function from the interpreted console. Okay, so I can actually exit out of this, hitting Control D. One of the other things that I can do is actually create a Python script, and the way that I'll do that is if I open up Sublime Text here, what I can do is I can make this a Python file, and I'll just say print hello world right here, and you can do this from any text editor that you want. And now what I'll do is go ahead and save this onto the desktop, and I'll save it as hello world with an underscore .py. I'll save it on the desktop right there. Great. So now if I go back to my console, and I can see here that I need to change directories to the desktop. And now what I'm going to do is I'm just going to write Python, and then I will write the hello world.py. And if we run that, it actually prints out hello world to the console. So whether I'm actually running this from the console or whether I'm running it from the script right here, it's going to do a lot of the same things. And the last things that I'll show you is something called IPython. So if you download one of those library installers, what you'll see there is that you'll be able to say pip install IPython. And IPython has a wonderful little add-on to it called IPython Notebook. So if I open up IPython Notebook, what it's going to do is it's actually going to launch a web server on my system. And so here I've launched IPython. So I can create a new notebook in IPython. And this is now running directly from my web browser. You can do this from Firefox, Chrome, Internet Explorer, Safari, whatever you're comfortable with. And essentially, what it allows you to do is enter code or markup or headings. So I can say, let's say I want to enter a markdown right here. So this is just text, and I'll say, this is an HTML file with Python executed code inside it. And if I hit Shift Enter, I can see that it just enters that code right there, right? Or enters that text. So now if I want to actually write Python, so it'll say print hello world, like that. I'll hit Shift Enter, and it actually prints out anything that's there, right? So any of the print lines that I put right here are going to happen straight onto this console. And this is a wonderful way to be able to show work, especially when you're doing homework, to show some of the things that you've tried out and the output of the system all in one. And then I can go up here to File and say Download as HTML, and then I can turn that into homework in using the turn-in system. Welcome to the session where we're going to talk about the basics of Python, the programming language. We're going to go over a lot of different syntax for how you use variables and loops, and also a lot of different data types that exist in Python. So the first thing you want to learn to do is how to make a comment in Python. And the comment is actually generated by the number symbol, the pound sign. Okay? So you can say pound, and then anything that happens after that is going to be a comment. It won't be looked at by the compiler. Also, whenever you're creating a file, a script, at the very top of the script, you can hit the exclamation point and then give it the path to where Python is installed. And that way, when you're actually running those files from the command line, you can use the // notation to be able to run those different scripts. If you don't want to put that at the top of you can always run the script by writing Python and then the file name .py, and it will run that Python file. So let's first talk about variable types that are in Python. Whenever you set a variable, that is when Python distinguishes and knows what type of variable that is. So if you were to say int underscore val equals 8, that means the integer 8 is going to be stored inside the variable int val. And again, we never declared any of the variables int val. So a long value, if I have the variable name long value, long underscore val, we can set that with a very, very long number ending with an L. If I want to set something to a float, I could say float underscore val equals 2.0. And that will set it to the value of 2. Bool values are given with keywords true and false with a capital T and a capital F. So if I wanted to run some of the following code where I said print variable type examples, now that is a string that gets printed, and then I'm going to print out the type of each of these. And type here is a function. You'll notice functions are given with an open parentheses and a closed parentheses, like many, many other programming languages. And the output of all of this is going to give me an output which says the type is either an int, a long, a float, or a bool. And again, none of these were declared as ints or floats or bools, and any of those values can change if I set them to different variable types. Now, because of that, a lot of times you'll want to know what it is, what variable you're working with. Right? And so you'll want to use a little bit of introspection to find out what the type of the variable is you're working with. And the way that you can do that is with this function called isInstance. So you can write isInstance, open parentheses, the variable that you want to work with, and if it's of type, the variable type that you're interested in. So for instance, if we say isInstance float value, and then we give it the float command, and it's going to check whether or not this is equal to a float, and that's true. If that was an int, it would have given us back false. Now that we know a little bit about the types in Python, I'd like to talk about what it means to do arithmetic and casting of the different variables. So when you divide two integers, let's say you divided 8 divided by 3, and they were both integers, it's going to do integer division, which means it's going to give you the number of times that 3 goes into 8, and that's twice. If, on the other hand, we were actually able to say, if we said that 8 was a float divided by 3, then it's going to do some of the arithmetic. It's going to cast all of the variables that are there. If they're integers, it's going to cast them to floats so that we have better precision. And the actual value is going to come back as 2 2/3. And that's true whether or not we cast both of the variables or just one of the variables. When we're dealing with logicals, we can actually use the AND the AND command. We can also use other types of conditionals that we'll get to later on. So if I were to say true and false, well, then the answer is false. If I were to say 8 equals 3, so does 8 equal 3, that would be false. Is 5 less than or equal to 6? That's true, and so the output is true. When we're doing multiplication, we can say 2 times 4, and we use this familiar asterisk. When we're doing modulus, or we want to look at a remainder, so what is the remainder when you divide 65 by 6? Well, you have 5 remaining. Also, when you want to take a variable to a power, you use the asterisk, so times, and that says 3 to the 4th power, and the output is 81. So now let's talk about strings and string operations. Strings are really a workhorse variable when you're inside Python. So for instance, if we wanted to set a variable to a string value, we can say, we can use double quotes, and we can say string value equals a string is double or single quotes, and that's the actual value of the string, and it's in double quotes. Now if we were to print that out, it would print out what it is that we're seeing inside the string. It would print out the contents of the string. We can also have a string which is set by a very long string that's going to come over multiple lines, and we want to do that. We're going to use 3 single quotes back to back. And so that means the string is going to go over multiple lines. Now, it also means that when you print that string out, any carriage return that you have at the end of these lines is also going to be saved inside that string. So you can kind of think of a /n happening right here at the end of that string, and that gets saved. If for any reason you didn't want that to happen, then when you say that a string is going to span multiple lines, you can just put this / operator at the very end, and that's going to consume the new line so that it's not part of the string. So we can also do various operations on strings. Strings, you can think of them as arrays of characters. So if we were to say string value, where we just set string value to a string is double or single quotes, if we were to print out the 0th character, that's going to be the character A. If we were to print out, and we can use this kind of different type of indexing for the array, that means that we want everything in the array from 3 to 5, but not including 5. So that's going to print out the characters TR, right? So that's part of the string, STR. If we want to print out the very last character, the last element in the string, we can actually use the -1 command. So it's going to wrap around and go and find the very last character that's at the end of the string. If we want to go back for the last 5 characters all the way to the end, then we can type -5:, and then leave the last blank, and it's going to say, okay, from -5 all the way where the end of the string is. And that comes out as the very end of the word quotes. The way that we can also concatenate strings together when we want to put 2 strings as one, well, we can say strval from 0 to 5, concatenated with the string values from 5 all the way to the end. So essentially reproducing the same string that we had, and we would get out a string as double or single quotes. Now, one thing to keep in mind is strings are immutable, so we can't actually set a character of a string after we've created the variable itself. So if we were to try to say string value at the 5, well, we want to change that character to be equal to g, that's going to be an error, because that's an immutable data type. Once it's created, we've said that that is the value of the variable, and it's not going to change. Finally, there are a couple other things that we can do with strings. So if we do multiplication of strings, that's like concatenating the string. So ×2 would be, say, adding it twice. And that's the same thing. So we would get a string is double or single quotes repeated 2 times. If we were to say ×3 or ×4, it would be repeated 3 or 4 times. Also, if we want to compare strings, it's going to compare them alphabetically. So if we were to say Python is greater than Java, the value would be true because it comes before it alphabetically. If we were to say call some of the built-in functions that happens to string in Python, such as the capitalize function, then I could say Eric.capitalize, and that means that the output of that string is going to be Eric with a capital E. We can do lower, which means make everything in the string lowercase. We can do upper, which is make everything in the string uppercase. We can also use this really neat function called split, where I tell it to split the string into by commas. So every time we see a comma in the string, split that and create an array. Right? And so we can have an array of the different strings that are in there. So if this is separated by commas, or commas are in each of those, we can call the split command, and we get back a list of strings. This is separated by commas. So now that we know a little bit about Python strings, let's talk about lists and tuples. Lists are really the workhorse of the programming language of Python, right? With a list, you can store just about anything inside of the container, and it really is just a container. You can carry in lists numeric values and strings. So if I were to say a underscore list equals, and then I'm going to have an open square bracket, and that's how Python knows that this is a list that I'm saving, and I'm going to say 45, 67, and a string. This is not a number, right? Again, I can store anything. Complex objects, I can store other lists inside lists. And once I've created a list, it's not immutable. It's absolutely something that I can append to and do complex object sorts with, right? So if I were to say a underscore list dot append, right? So the dot append notation says that I'm going to append a value to this list, and then I'm going to say a string appended as a new element in the list. And if I print out the list, we can see that I've got the two numbers, the not a number string, and then the last string that I appended onto the list, and that's an entry. Lists can also have other lists in them. So if I create a list called temp list, and append temp list onto my a underscore list, then what happens in there is, it's a little bit difficult to see, but essentially what happened in here is there's another square bracket of a list. So if I were to grab the last element on a underscore list, it would actually return the entire temp list back. And again, all of the indexing that we went over with strings, you can also do with lists. So a underscore list at the -1 will get you the last element, -2, and then an open colon will give you all the way to the very end of the list. So that will print out the two last values in this list. Tuples are very, very similar to lists in that you can store anything in them, complex objects, anything. But a tuple is immutable, and that means that once you've created it, it is set. You cannot change that memory. So if I were to say the same kind of thing, I don't have a square bracket here, so I'm just going to denote these things by commas, and when I do that, that lets Python know that this is a tuple, not a list. So I'm going to say 45, 67, not a number. And now when I print out a tuple, instead of having the open square brackets here, I just get these parentheses right here, and that lets us also know that that's a tuple. So if I access a underscore tuple at the second element, right, so 0, 1, 2, that's going to give me this very last element right here, that gets me not a number. If I try to change memory inside of that, I'm going to get a type error in Python. In addition to lists and tuples, we can also use sets. Sets are a native data type in Python. And the way that you create a set is using the set function. So let's say I have a list, and inside that list, I'm going to call the list basket is equal to apple, orange, pear, orange, and banana. When I save this as a set, essentially what it's going to do is it's going to create a set without any duplicates in it. So if I had duplicated memory over here, such as apple, it's just going to store that as one single thing in the set. So sets do not have repeated values. So if I were to print this fruit set, I would get orange, pear, apple, and banana. And the best way to think of that is this set is just a really big basket. And whatever I throw into it, it's only going to allow me one thing inside of that set. It also is going to provide us a really, really quick method for testing whether some type of variable or a variable itself is inside the set. It's very fast membership testing. And the way that we do membership testing is using the in keyword. So if I were to say orange in fruit, that's going to tell me whether or not the variable orange is inside of this set fruit. And that's true. If I were to ask for crabgrass in fruit, that would return false, right? Now, the only difference between lists and tuples and sets is that sets cannot hold complex objects. You have to have something which is what's considered hashable data. Hashable data is usually reserved to primitives that we can actually apply something to and come up with a unique key for that variable. So complex objects, lists, other sets, those are going to be things that we won't be able to save inside of a set. So for instance, if I tried to create a set where the very last element of the list was another list, 5, 6, I'm going to get an error in Python. So again, there's also a lot of different operators that we can do with sets. They're very, very interesting. So I'm going to have a set A, and it's going to be the word abracadabra. I'm going to have a set B, and that's going to be the word alakazam. Now, if I say a.add the exclamation point, that's going to add that letter as one of the things in the sets. So I'll print out the set A, and you'll see that it's unique characters that are in abracadabra with the exclamation point. If I print out A minus B, that's going to be all of the letters that are in set A, but not in B. If I print out A or B, that's going to be letters that are in either the set A or the set B. If I say A and B, that's going to be letters that are only in both sets. And then if I have this caret right here, this is an exclusive OR operation. So all of the letters that are in A or B, but not both. So it's an exclusive operation. With Python sets, there's also the notion of something called a frozen set. And a frozen set is immutable memory. And that means once we've created the set, we can't change it. We can't use the add function, right? So if I say frozen set A, it's going to create an immutable set. And if I try to add to that, Python's going to give me an error. So finally, let's talk about Python dictionaries. Dictionaries map a key and a value to one another. So as before where we had lists, lists were basically something that we indexed into. However, now what we're going to do is for every element inside the list, let's say we have an integer, a string, a float, and maybe something to another list, the way that we're going to access that is through some key. Right? So the way that we create a dictionary is going to be, let's say we create a dictionary called num_legs, and we say that equals open curly braces. That's how we know that this is going to be what we're setting as a dictionary. And I'm going to give it the key, colon, the value. So numlegs at dog equals 4. Numlegs at cat equals 4. Numlegs at human equals 2. So if I were to print out, let's say, numlegs at the dog, I would get 4. And the way that I address into that is using the key. Numlegs at human, well, that equals 2. So we can add a lot of different entries into these. And again, if one of these entries inside numlegs doesn't exist, it will actually create that key and set it to the value that I've given it, right? So I've set numlegs human now equal to the string 2. And that overwrites the memory that's there. And then I've created a new key value pair just by saying numlegs at the bird equals 2 and some wings. But there's no reason that that key has to be allocated memory that is a string. It can also be any immutable memory at all. So if I say numlegs at 45 equals a key that is not a string, then I can print this out, and what I'll see here is that a key that is not a string, that's the key for getting into the variable. And the value 45 is the key for getting into that, and the value of that key, 45, is a key that is not a string. I've also now deleted numlegs of the cat, which you can see inside the Python dictionary. Welcome to a new session where we're going to talk about a little more advanced Python, where we're going to get into loops, conditionals, and also talk about what it means to write Pythonic code. So let's start with Python loops. The first thing that I'm going to do here in some of this line of code is I'm going to use an import statement, and I'm going to import random. And what that does is it imports a library that I have installed on my computer, and that library is random, which ships with Python. So by importing that library, it essentially works like many other object-oriented programs where I can now have access to all of the methods, all of the functions that that class employs. So the random class has a function in it called randint, and that's going to return a random integer, and if I give it the bounds of that, it's going to return a random integer between 1 and 10. So now what I'm going to do here is I'm going to set a val equal to 0. And this is an integer, because the type is inferred. And now what I'm going to do is call a loop. I'm going to call a for loop. And the for loop that I'm going to have is for I in the range of 0 to some random integer between 1 and 10. And what that is going to do here is it's going to say I is the variable that I'm incrementing. For int I, going from 0 to some random integer between 1 and 10. And that integer could be anything between 0 and 9. Right? So there's some random amount of iterations that it's going to go through this for loop. Right? This is very, very similar to a for each statement. So for each I in the range, you can kind of think of this as an array that goes from 0 to possibly up to 10. What I'm going to do is I'm going to say value plus equals I. So this plus equals notation is very similar to Java, C, and C++ notation, where I'm going to take the value and increment that value by the value of I. Then I'm going to print the value. Now if value is ever greater than 20, I'm going to print out this line right here, which says I'm leaving the loop on a break. And then I'm going to have a break statement, and that is going to exit out of this entire loop. Now if value is never above 20 and I exit the loop, then this is going to be a little bit wild if you're used to other programming languages. It's going to execute an else statement. Right? So if I were able to go through this entire for loop, and whenever this condition up here, I've gone through all of the conditions, whenever that's true, I'm going to go to the else statement and say print exiting the for loop without a break. So that else statement only gets issued if this break statement never occurs. So if value gets incremented but never gets above 20, then we'll see this else statement. So when I first run this code, what I'll see here is that I'm printing out the value of val, which is 0, 1, 3, 6, 10, 15. It got all the way up to 15, but then it exited out the loop before it was greater than 20, and so it issued this else statement, which was exiting for loop without break. Otherwise, we can see that the value, if we run it again with another random integer that we're going to count to, I'll get to 0 all the way up to 21, and now this conditional right here, this if value greater than 20 is met, and I can say that we're leaving the loop on a break. Now, when you're doing for loops here, indentation in Python is everything. So one tab over, that means that I'm inside of this for loop. All of the code inside here is in this for loop. How I know that this code right here is inside of the conditional is it's also tabbed over. And the only way that I know that I'm outside of the scope of this for loop is by getting tabbing back over. So I'll say if is on the same scope here as this else statement is on the same scope as the for loop. And then again, I tab over to let me know that I'm inside of this else statement. Right? So it's a little bit different than other programming languages you might be used to. Now, in addition to for loops, there's something that we could do here with implementing for loops with lists. So if I create a list example variable here, and inside of that I create, I just save my int, long, float, and bool values that we created in another different session. I can also say, well, list example.insert data mining. Right? So I'll insert the string data mining at the 0th position. And what that's going to do is move everything over to the right and insert. So once I have a list function right here, what I can do is print out the values in the list. And the way that I can do that is using a for loop. So for val in list example, I can print out the string equivalent of value and concatenate that with the type that it is. So this is just going to print out a string, which is the value converted to a string, and the type of the variable. Right? So if I were to run this code right here, and I would also print out this statement is in the loop, and print out this statement is outside the loop, what I would get here is I would get data mining of type string, 8 of type int, this value of type long, 2.0 of type float, and true of type bool. And interspersed in between, I would be printing out this statement here inside the for loop until I get to the very end, right, where, again, this indentation, I've taken back off the indentation. So it's equal with the for loop, which means it's not inside the for loop. So this statement is outside of the for loop there. So the other thing that I can do is have some loops with lists, right? So essentially, some of the other functions that I can call to help me call for loops with lists are going to be the enumerate function. So if I call enumerate the function on list example, I can write a for loop that says for the index and the value in enumerate list example. And what that's going to mean is that every time I loop through this, index is going to have the value, the index at which we're at in the list example, and the value of what's in the list. So if I were to print out the value is at index, and then I print out the index, I can see that data mining is at index 0, 8 is at index 1, and so on and so forth, all the way down to 4, where I have my bool value. So this enumerate is really good for being able to know where you are inside the list. Let's say you have 2 lists and you want to sort through them, or you want to write a for loop to go through each of the lists. Well, what I can do is I can say for QA in, and I'm going to zip these lists together, zip question and answers. And what that's going to allow me to do is go through each of these one by one. So the first time through, Q is going to have the value name. A is going to have the value Lancelot. Right? So what is your name? It is Lancelot. You'll notice I'm using the Pythonic conventions here for Monty Python. What is your quest? It is the Holy Grail. And so it goes through each of these in succession with one another. So now that we know how to loop through lists in Python, let's also look at some different ways that we can loop through dictionary variable types. So when you want to go through and look at the keys that are inside of a dictionary, well, what I can do is I can go back to my variable numlegs, which we created before as a dictionary, and I can say numlegs.keys. And what that's going to do is it's going to return all of the keys that are inside of that dictionary. And I can go through and I say for k in all of the keys that exist, print out the key, and then I'm also going to print out numlegs at the key right here. And the output of this for loop would be bird, 2 and some wings. The key 45 points to a key that's not a string. Dog, 4, human, 2. Just like we set up last time in our Python. Now, instead of accessing numlegs with the key that actually exists right there, another way that we could do is by calling the iteritems function. And this is going to return an iterator so that we can go through the dictionary. So for the key value in numlegs.iteritems, I can print out the key and the value that's there. And it's going to print out the exact same loop that we saw before. This is just maybe a little more compact, a little more Pythonic way of going through dictionaries. Finally, what we're going to look at is testing for the presence of a key. So I can say for t in, and then give it a list of a lot of different values that might or might not be inside this dictionary. I can print out the value of t, and then I'm going to write a conditional here that says if numlegs.hasKey, which is a function, part of the dictionary class, if it has the key, go ahead and print it out. Otherwise, I'm going to print out is not present. And the output of that code right here is going to be that human points to 2, beast and cat are not present in the value in the dictionary, and then we can print out the values of dog and the key 45. So now that we know a little bit more about loops in Python, let's talk about an extension of loops called comprehensions, which is a really interesting way of saving data inside of a list using a loop kind of style format. So imagine that we want to take the values 0 through 9 and take each of those values to the 4th power and save them into a list. We could write a for loop where we actually did that and appended the value to the 4th power. But Python creates a really concise, really understandable syntax for doing that, and it's called a comprehension. So let's say we wanted to create a variable called times_4. What I'm going to say is equals the brackets around this statement. I'm going to say for x in the range of 10, so for x being in the list 0 to 9, take x to the 4th power and save it inside of the list. So what it's going to do is it's going to say x to the 4th and save that each time we go through the iteration as an element in the list. So if I were to run this piece of code and then print it out, what I would get here is 0 to the 4th, 1 to the 4th, 2 to the 4th power, all the way up to 9 to the 4th power. And this is a very readable, very understandable way of going through the code and creating new lists and new variables. And anything that I can do inside of a list, I can also do inside of a comprehension. I can have some very detailed comprehensions. So I could call a function on the value that I'm going through. So let's say I have a variable, a list of questions, which are strings, and each of those strings are name, quest, and favorite color. Then what I can do is say quest_upper, create a new list. I'm going to say for x inside of questions, call x.upper, right? And x, that's a function which is attributed to the class string, so I can call the string variable here. If any of these variables weren't strings, calling x.upper would be an error, right? But now if I print out that, it's going to be the uppercase equivalent of each of those. Now comprehensions aren't just limited to lists. I can also do dictionary comprehensions. So if I wanted to create a new dictionary, then it's very, very similar syntax. I open the curly braces and say for x in the range of 10, then save the key as x, the value x to the 4th, right? So it's a very powerful way of saying this is the key, this is the value that I want you to store in this times 4. So now if I were to print out this right here, the key is going to be the index, so 0, 1, 2, all the way to 9. And then the value there is that value taken to the 4th, which we just saw up here in the list. So you could imagine doing a lot of different things with this type of comprehension format. And again, if you wanted to do comprehensions, all of the enumerate and zip examples that we had before still work with comprehensions. So if I wanted to say for x and y in zipping the x array and the y array here, it's going to go through these element by element. I'm going to multiply them together, and it's going to return a list, right? So it's going to return a list which is 10 times 7, 20 times 5, and 30 times 3. And now, since that list exists, I can call this function sum, right, which is built into Python, and it's going to sum all of the elements in the list. So it creates a new list, which is those multiplied by one another, and then adds them up. And if you think about that, that's just the dot product of those two vectors, if we wanted to call them vectors. And this is a very compact way of representing that dot product. So abstract data types in Python are really the bread and butter, and they're really the bread and butter of every programming language. So let's go through a few examples of things that you've probably seen in other different programming languages and how they're implemented in Python. So let's first talk about stacks and queues. If you wanted to create a stack example, it's essentially creating something where the input and output are last in, first out. So whatever variable you put into a stack and you pop that off the stack, that's going to be the value that you pull off. So if I'm putting the values in, say for here, I put the value in 3, and then 2, and then 1, and then 0 into my stack. Once I pop off the first element, it's going to grab the top of that. So if I were to give a list example, and I was to create a list, which is appending the last in, first out string as the first element, and then I append on 0, 1, 2, 3, and 4 into that list, I can call listExample.pop, which is part of the list format. So I'm using a list here as a stack. I pop that value off, and the value is equal to 4. And now list, that value is gone, right? Last in, first out. For a queue, I can do something very, very similar. With a queue, it's first in, first out. So the first element that I put in for this queue is going to be the value FIFO. And the way that I create this is I'm going to say from collections, import DQ. So collections is a library that ships with Python. And the function, the class DQ that's inside of collections is actually just the queue format. So now I can create a queue called queueExample, that equals DQ, the default constructor. And I'm going to say queueExample.append left, right? FIFO. And then I'm going to append the values 5 all the way to 9. So in the range of 5 to 9, I'm going to append those left onto the queue. And now I can pop those off of the queue, and that's going to be the same as taking them out at the very end of our DQ operation, right? So if I were to actually do queueExample.pop, I would get FIFO, the first element that I inserted into the queue, and then I can print off the queue example. That value has been consumed off of the end of the queue list. Conditionals in Python are something that are very similar to other programming languages. So let's say I create two variables, A and B, and I'm going to set them equal to true and false. Notice I'm using some Python syntax here where I have coupled the assignment of A equals true, B equals false right here. So what I'm going to do is say if A, open colon, I'm going to print A is true, right? You'll have to have this colon here. And again, the indentation lets me know that this is part of that conditional right here. Then I'm going to use the syntax elif A or B. And this says if A is true, print this. Otherwise, if A or B is true, print B is true. Else, print neither A or B. So very, very similar. This elif is the else if statement for Python. Right? So if I were to print out this value right here, since A is true, it's going to output A is true. Now I can also save the values. I can do conditional assignment. So in C, this would be similar to using the question mark operator, where I'm going to say value is equal to B is true if B, else it's going to be equal to B is false. So this is very readable code right here that says B is a conditional. The value is going to be equal to B is true if B is true. Otherwise, it's going to be equal to B is false. I'm printing out the value here that says B is false right here, based on the operators that we have in this conditional. So again, there are some keywords that we can use here. The keywords are and, or, is, and not are going to be what we use mostly for checking equality. So let's say that I have the conditionals here, where I want to say if A is equal to B, I'm going to print out everybody as a 5. And what I've done here is set A and B equal to 5. Otherwise, I'm going to print wish we had 5. By executing this code right here, both A and B have the value that's equal to 5, so I print out everybody as a 5. Now, the is function is for object comparison. What I'm asking here is, are A and B the exact same object? So what I can say here is, if A is B, so not are their values equal, are they the same memory? This would be kind of like pointer comparison if you were going to use that in C++. If A is equal to B, then I'm going to print out these are the same object. Otherwise, wish we had the same object. By executing this code, I'm going to get these are the same object. Now, what I'll do here is I'm going to set A and B are going to have the same value as one another, but they're not going to point to the same memory. So if I call if A is B on this assignment that I've done right here, it's going to say wish we had the same objects, right? So that's the is operator. Okay, so I've told you that the is operator only compares memory, and that's when we're going to get down into a little bit of the specifics of the way that Python solves memory. So the values that I had before were very large values, very large integers. When I save the values in memory for small integers, it caches those types inside of memory. So if I were to say A equals 5 and B equals 4 plus 1, We would think that if we said if A is B, it would say, no, wish we had 5s, because they're not the same object. However, right now, they are pointing to the same memory in Python, because it's cached these small integer values. So by calling this, I get print, and it's going to say everybody is a 5. However, if we change that memory, the caching of the memory gets released. So if I were to say B is equal to B times 2, and then B is equal to B divided by 2, those are now going to occupy different places in memory. It hasn't cached them as the same memory. And by calling if A equals B, I will actually get them as separate objects. Finally, one of the things that you can do with conditionals is you can have nested conditionals for bounding. So I could say if 5 is less than 8 is less than 6, right? So looking at 2 different conditionals that are nested, I'll print out how did we get here, because 5 is obviously not less than 8. 8 is obviously not less than 6. But else if 4 is less than 18 is less than 22, this whole conditional is true. We'll get out print got through a nested conditional. And that's exactly what happens. So now that we have a basic understanding of the syntax for loops, conditionals, data types, and how we can use Python, let's talk a little bit about what it means to write Pythonic code. So there are many different coding styles that you can use with Python, and that's especially true for Python 2 versus Python 3.0. There's a lot of different ways that you could accomplish a lot of different tasks, and so a lot of those styles are going to be not quite as good as some of the other styles that people have found while using Pythonic code. So the best styles of coding get the distinction of Pythonic, and that's really an ill-formed definition right now. It changes as the language matures. As people get better at writing code in Python, there are different distinctions for code that is Pythonic. But essentially, the best code is one that is readable and easy to understand. Right? It uses dynamic typing when possible and to your advantage, right? Because these variables can take on any value, any type of memory, that could be a real advantage in the way that you write code. Or if we want to quote someone called Tim Peters, we can type import this into the Python command line, and it's going to give us the Zen of Python by Tim Peters. So I'll let you go and read that. But essentially, he's going to tell you things like beautiful is better than ugly, sparse is better than dense, errors should never pass silently, right? Now is better than never, although never is often better than right now. So there's a lot of different things and conventions that you want to use while programming. And what you'll notice here is none of these are hard and fast rules. They are completely subjective, completely open to interpretation. And that's good, because as a programmer, I want you to be the one that's writing code and deciding whether that code is readable and well understood by someone that's going to read it, right? Because you got to remember one thing. As many times as you write code, 1,000 other people are going to read that code. It's more important for the code to be readable than it is for you to write something very, very quickly. And again, Python is a little bit of a quirky language, but don't let that mystify you into believing that it's not a serious tool. At one point, when we said C++, that was a funny name for a programming language, right? Python is a little bit the same way, but it's a very serious tool. So there's too many Pythonic conventions to go over. Please go on to the course and look at some of the links that we have to the Python conventions that you might want to look at. One of the ones that we will go over is that when you write variable names, separate the names with underscores and use completely lowercase letters. So if you had a variable that you wanted to call this is my variable, it would be this underscore is underscore my underscore variable. Use indentation in your code to increase clarity, right? If you need to have things go over to one line, be sure that that's indented over. Use spaces before assignment operators. For example, x space equals 5, right? X space equals space 5. And space mathematics properly, such as if you had hypotenuse squared, hypot2 equals space x times x space plus space y times y. X squared plus y squared. And this is a very readable way of entering that code. So now that we know what it means to be Pythonic code, or we have an idea of what that definition is, let's put it to the test. Answer these questions on what the most Pythonic way of writing the code for these questions might be. Welcome to this session where we're going to talk about object-oriented programming in Python. So before we talk about what it means to write a class, we need to talk about how we define functions in Python. So this is going to be how we write functions that don't necessarily belong to a class. These are much more procedural functions, right? Things that we can just define and call and use, much like we would in a C programming language. So the way that we create a function is by using the keyword def, D-E-F, as in define. And what we're going to do is say def, and then we're going to put the name of the function and any inputs that we expect to come to the function. Now again, Python is weakly typed, so the variable that we're putting in here can be of any type to this variable. So when we say, we ask the variable make strings lowercase, and then we give it the input variable named string input, we'll do an open colon and put an indentation here so that we know all of this that we're about to write of the same indentation is inside the scope of this function make strings lowercase. And the first thing I'll do is test whether the instance that I'm about to have, the instance that was put in, whether or not that's of type string. So I call this introspection method is instance, the variable input, of type string. If it is, go ahead and go on. If it's not, I'm going to call an error here using the assert function. Right? So the assert macro. If it is, what I'm going to do is say return this variable dot lower. Right? And that's going to make it lowercase. Now notice I haven't defined the return type on this function. It's inferred by what I return here inside the end of the function. And actually the return types can be dissimilar based on things that happen inside the code. So if I want to call this function, I'm going to make sure that this function is defined somewhere before it gets used. And that's the only caveat that I have when using Python. This has to be defined higher in the file where I'm using it, right? And that's something that's very, very similar to a lot of different programming languages like C. So if I print the output of make strings lowercase and I give it the variable uppercase, it's going to print out uppercase. If I give it make strings lowercase data mining, it's going to print out data mining because I'm printing the output of the function. So this is a very toy example where really we're just calling another function right here and we're adding this assertion of introspection where is that a string so we don't call it as an error. Okay, let's do something just a little more complicated. So let's define a function called show underscore data, and I'm going to put data into it, and the only thing that it's going to do is print that data. So there is no return type here. So if I were to say sum data equals a list, and I call the data show data on this, it's going to print out that data regardless of the data type that I put into it. Now, if I were to set something equal to the output of show data, if there's no error inside of that function, it's going to return the type none. And that's capital N-O-N-E, none. And that is a variable type in Python, which lets you know that variable is basically null. There's nothing in it. Now, let's redefine that show data function. And now what we're going to do is we're going to give it more inputs. We're going to give it the data that we want to print out. We're also going to give it variables x and y. And we're going to give those variables default names or default values. So I'm going to say x is equal to none. Y is equal to none, right? So essentially what that's saying is if the user doesn't provide the variable values for x and y, I'm going to make those equal to none. Then I'm going to print out the data, and I'm going to print out x if x is not none, and I'm going to print out y if y is not none. So now I'm going to create some data equaling a list 1, 2, 3, 4, 5, and I'm going to say show data some data, and the output of that is just the value of the list 1, 2, 3, 4, 5. Now if I call show data some data with x equals some cool x value right here, and you'll notice that I've actually said x equals inside of the function that I'm defining right here. And that lets it know that x is going to be equal to a string. When I call that, it will print out data, the list. It will also print out a cool x value. The value of x is a string. Now, notice here that because I've defined x equals and y equals, those can be put into the function in any order I want. So I can say show data some data right here because that's what it's expecting as the first argument. But now I can say y equals a cool y value and x equals a cool x value, right? So I've put those in reverse order up here, And Python's fine with that. It's going to set x equal to this and y equal to this because I have this operator to disambiguate that. So when I call that function, I'll get the list, and then it will print out x first and then y at the end. Now, another thing that's really, really wonderful about Python is I don't have to return one value. I can actually return a tuple. And that's really interesting. So if I define get square and 10th power of x, I can return x to the second power, comma, x to the 10th power. I'm returning a tuple right here. So if I were to say print get square and 10th power of 2, it's going to return two variables to me, 2 to the second power and 2 to the 10th power. So I'll get 4 and 1024. Now this is very, very powerful because it means that I can return any number of variables that I want without having to make that object oriented. So now that we know how functions work, let's look at how class structures work in Python. So what I'm going to do here is define a class called bodyPart. And the naming convention when you're doing classes in Python is to make each of the words capitalized. So I'm going to have a class called bodyPart. I'm going to have bodyPart. You'll notice I have an open parentheses, object, close parentheses. And what that tells Python is that bodyPart is going to inherit from the generic object class. An object is just the generic Python class. So I'm going to have it inherit from object. Right? This is very, very similar to other programming languages that have default objects that you can inherit a class from. So whenever I define a class right here, one thing I need to define is my constructor. And the way that I can define the constructor is with the init command. So I'm going to say underscore underscore init underscore underscore. And then I'm going to have open parentheses self and name right here. So self is something that you will always have to put into the class because you're essentially passing the instance of the class into this function. The next thing I'm going to do is I'm going to pass in an optional, I'm going to pass in a new variable called name. Okay? And so I'm going to define this initialization function as self name, and I'm going to say self.name equals name. And what that tells it is name right here is going to be a member variable of this instance of bodyPart. And I'm going to set it equal to name, whatever the user passed in. So to make this a little bit clearer, if I were actually to say bodyPart equals, and then give it a name of leg, then it would create a new instance where the bodyPart.name is equal to leg. Now I can also, now that I have bodyPart defined, I can create a new class that inherits from bodyPart, right? So if I want to define the constructor, the initialization function, then here what I've given it is init, and I've passed the instance itself, the new instance that's created. But then I have two other variables that have default values, where the rate is equal to 60, units is equal to minute. Right? So this class is called heart, and it has the properties of rate, so you have a heart rate, and the units that rate is in. So when I want to create these as part of the instance, I'll say self.rate equals rate, self.units equals units. Now the next thing that I want to do is I also want to call the superclass from heart, which is bodyPart, and it inherits from bodyPart. So I want to call that initialization function. And the way that I do that in Python 2 is I'm going to call this keyword, this function, where I say super heart self, and that tells it go into the superclass of heart, given this instance, and that's bodyPart, and call the initialization function with the name heart. So this right here will actually pass in the unit, so it'll take self.name and set it equal to heart using this functionality. So whenever I create a new variable right here, my heart is of the class type. It's going to have a rate of 1 beat per second right here. And also, if I were to call my heart.name, the name of it would be heart because we defined that here in the initialization function. Now, you can also have any methods that belong to this class. And the way that you define methods is with the def function that is indented inside, so we know it's of the class scope. So now, whenever I call print rate, again, I'm going to be self as the initial variable that gets passed in, and that happens automatically with the class. So I'll say, if I define my heart equal to this, and say my heart.print rate, and again, I'm not giving the input right here, even though self was established here. I'm going to say print name, print the name, has, print the rate, beats per, and then print the units, like this. And what that's going to do is whenever I call this print rate function, it's going to spit out name heart has 1 beats per second. Right? And so this is just kind of a toy example on how we can define classes and how we deal with inheritance in Python. So let's also go over what it means to have a member variable versus an instance of the class variable. So if I were to say class body part, and again it inherits from object, if I were to give it the value kind right here and say kind, this is a long string meant to be so long that the memory for it is not cached by Python, because again Python caches memory. This variable right here, that is going to be unique only to the class itself. So anytime if I create two instances of the body part class, those are going to share the memory right here, which is kind. So let me give you a little bit of an example of what I mean by that. Let's say I create this myHeart variable, which inherits from body part, and I were to print out myHeart.kind right here, right? Then what I would get is, it's going to print out the string of kind, right? So whenever I created that, it created a new variable kind. Now if I create another variable from the body part class and I name it foot, so that generic body part, then if I test to see whether or not myHeart.kind is the same variable that's in this instance of generic part.kind, I'm going to get back the value of true. So this .kind variable, that is shared memory. There's only one instance of that for the whole class structure of body part, right? So for instance, if I were to say A is equal to that long string and B has the same value, those do not point to the same memory location. But when we're actually looking at it as part of the class structure, they do. So now that we're getting familiar with classes in Python, and again, don't be troubled if everything is kind of a little unclear right now, because really when you're learning a programming language and the syntax of a programming language, that doesn't really make sense until you go in and try to implement some things yourself. So let's go on from classes and talk about exception handling in Python. Because again, we don't want errors to happen in Python at runtime. We want to be able to catch those errors and handle them appropriately. So here's what I'm going to do. There's some code that I have that's going to import the random class. And what I'm going to do here is create two different variables. And I'm going to create a variable I and a variable j in a random range from 0 to 8 and -1 to 6. So I'm going to get I and j back as integers. Now, what I'm going to do is define a list called sum, S-O-M-E. And I'm going to use the keyword try right here, which means that any exception that happens inside of this try block, I want to catch those exceptions and handle them appropriately. And the way that I could do that is using this try and except keywords. So the except keyword is going to say, if a error happens of type 0 division error, go ahead and print out division by 0. Right? But don't raise the error. So this won't result in a runtime error. We'll catch the division error and print out this. If, let's say, inside of some of this code we get a type error, right, which means that there's a mismatch. We're trying to do something to a variable and the type just doesn't match for that. Then we can get, if it's a type error, we can also get this variable the detail of the exception, and we're going to print out what the detail of the exception is. And that's just a little more information about what the error was that we caught. And we can do the same thing with an index error, which means usually that's an out of bounds error. We're trying to index into a list past or beyond the length of the list. And then finally we can just do a generic except, right? Which is no matter what it is right here, let's just print something else went wrong, which means we haven't caught the exception explicitly, but any other exceptions that aren't these, we want to print out something else went wrong. We can also have something inside of this try block, which is an else, which means if we get all the way through this try block, none of the exceptions happened, then also execute this else statement, which is part of the try except block. Okay, so we've randomly initialized I and j. First thing what we're going to do is we're going to say, hey, denominator is equal to list at the j divided by I right here. So if we run this and the random values for I and j are 0 and 2, this is going to be sum at the 2 divided by 0. And that's an error. So what will happen is it will catch this error, happens right here, and will get sent to this division by 0 block. In the same respect, if the values of I and j are 6 and 5, then we're going to get down a little bit further into this, but essentially what will happen right here, we'll try to access sum at the 5. And that's an out of bounds error. So that's going to take us to this index error down here where it says some value is out of range. And the detail that it prints out is list index out of range. So it's something very human readable about what error occurred, right? So the detail. And again, detail was a string. Now let's say that we get randomly initialized values of here 4 and 4. I and j are both equal to 4. Well, actually, that's going to mean we get all the way down into this try block, and then at the very, very end, what we get right here is we're trying to print out sum at the k. And the problem here is that k is equal to a string, not a numeric value. So we're trying to access sum at the mic, and that's just not going to happen, right? So what that gives us is a type mismatch error, right? And the detail for it is list indices must be integers, not strings. Very human readable. But let's say we get the values for I and j of 4 and -1. Right? So if we get 4 and -1, that means that we got all the way through this try block, no errors occurred, and then we executed the else statement. Right? So when we're doing exception handling, it's very good practice to use a try except block right here to catch a lot of those errors. So now that we know about catching errors, let's do something in Python where it's actually useful. Let's read in from a file and set a variable called data equal to the contents that are in the file. So one way that we're going to want to do this is putting this in a try except block. So I'm going to say file is equal to open sumFile.txt, and this open function is going to go try and find this file, and if it exists, we're going to get a pointer to that file that's been opened, right? And then we can call file.read and read in all of the contents that are in that file and save it into data as a string. Now the problem here, there's a couple of things that could happen. First, sumFile.txt, that may not exist. And if that doesn't exist, we're going to get an I/O error. And specifically, if we try to call this block right here, we're going to say could not read file, no such file or directory, sumFile.txt. And that was the detail that we got from the I/O error. Otherwise, if that did happen, let's go ahead and print out read successfully, and then we'll print out data right here, which is the file contents. Now, I'm also going to do one more thing right in here, which is I'm going to call a finally block. So this finally block is going to get executed no matter what happens. Whether or not the exception gets happened here, whether or not I'm in the else statement, I'm going to get down to this finally block, and I'm going to say if not file.closed, if this file is not closed, close it. And that's always a really good idea, right? So if that actually happens, what will happen is we'll say, if we get this error, I'm going to go ahead and close out that file because file shouldn't be equal to anything right now, right? If we've read it, I still want to close the file and shore up that memory, right? So if it does happen, we'll get read successfully in the file contents where this is an example text file. So we just had one line inside that text file and it read out to be this. Okay? Now, one thing that's a little odd here is, gosh, it seems like we're going to do this kind of prototype where we'll have a try, except, and finally block. It seems like that would apply to a lot of different classes. And it happens so often that we have this try, except, and finally, where even if an error occurs or something happens really that we want to happen, we also want to shore up some of the properties of this file class. This happens so often that it's given a specific format called the with command in Python. And so essentially what that does is I can say with open some text file as file, and that's kind of the same as saying file is equal to open some file.txt. And then inside of this with statement right here, if that happens properly, then I'll say data is equal to file.read, print read successfully, and the file contents were data. Right? What that does is there are dedicated, so back here when we had our file data, there's some dedicated functionality that says inside the file class, once we get to the end of the with statement, whatever happens outside of this, we want to close the file at the very end. So there's some kind of exit protocol for when we're exiting the with statement. There's also an entrance protocol. And so if we go through this with statement and we say print is the file.closed, that's true, even though we never actually called file.close here. Once we got to the end of the with statement, it went ahead and called this finally command that's inside of the class right here that happens with. So to make that just a little bit clearer, let's write our own class that uses with. So if we want to use a class and we want to call the with statement, let's say that we actually wanted to execute with body part lungs as BP, and what that would be saying is BP is equal to body part with the name lungs. Then we want to call bp.printself, right? And there are a couple of functions that we're going to want to define with the with statement. The first, always with a class, we have initialization. We're also going to define this function called enter, so underscore underscore enter underscore underscore. And what that's going to do is I'm going to print out building up from with command. And then I'm going to return self right here. And what that means is that whenever I call with body part, it's going to call the initialization, and then it's going to call the enter function right here, and it's going to return this value right here. I'm going to return self. So self would be entered into this BP. The instance variable would get that self. I'm also going to define an exit protocol, which also this would be called if an error had occurred. So I'm going to have this value right here that gets part of the exit protocol. If value is equal to none, if value is not equal to none, that means that there's some kind of error that occurred. So I'm going to print an error occurred, and I'm going to print the value of the error. If it is none, that means that we're fine. Exit was called no errors. So I'll also have this print self function right here, which says print, hi, my name is, and print self.name. So if I call with body part lungs as BP, and then print out self, what it's going to do is calls the initialization function, then it calls the enter function, then it executes everything that happens inside this with statement, and finally exit is called and there were no errors. So if we want to see what happens when there's an error, what we can do is introduce a divide by 0 error, 5 divided by 0. I'm going to uncomment that in the print self function. And when I do that, what will happen is with body part lungs as BP, I'll go into the initialization function, then I'll call the enter function, just as always. But now when I try to call BP print self, it's going to raise an error of division by 0. So that division by 0, the first thing that's going to happen, it's going to call my exit protocol right here. And it's going to give it the type and value of the error that is there. And so what I'll do is I'll print out an error occurred right here, integer division or modulo by 0. That was the value of the error that was returned. Then, after my exit protocol has been called, it's going to go ahead and raise that error. It'll generate a runtime error using the with command. So, using that, you now have kind of a crash course in all of the syntax of Python. So now I want you to go onto the course and look at what the assignment is. We'll have a programming assignment to do with Python and really shore up a lot of this syntax so that you're very familiar with the program, the Python programming language. So let's talk really quickly about importing libraries into Python and how you can import third-party libraries, because when we start doing a lot of databases and data science type things, a lot of those external libraries are going to be very, very beneficial, something that you really want to have while you're running your Python code. So let's talk about that. So on my system, I'm running on a Mac, and I've installed pip, which is a library manager. So if I open up terminal here, here's what we'll see. What it can do is try to install some different libraries from Python. So the first thing I'll write is, let's do pip install, and the first dependency that I want to install is IPython. So we talked about IPython earlier in the sessions, and this was something that allowed us to write code inside of an HTML web page and have that get executed in the output displayed underneath the HTML code. So if I type that, right now it's already installed in my system, but on your system this would actually go out, figure out what the dependencies for IPython were, and allow you to go in and be able to run any of the different IPython things, such as the IPython notebook. Another dependency that we should install, let's do NumPy. So I'll write pip install NumPy right there. And that is, again, it's already installed on my system, but it's a matrix manager so that we can save arrays as matrices and do fast matrix multiplication. And that'll become really important later on when we talk about data mining in the master's program. Let's also install some visualization software. So let's install Matplotlib. And again, all of that has actually been installed onto my system. And that's going to be a visualization software where we can plot different matrices that are in NumPy. So what I'm going to do right now is go ahead and install those on your system. And then once you've installed them, I want you to type IPython notebook and see if you can actually run the notebook. And if you can't, try and figure out what dependencies you're missing and install them. So I'll start with running the IPython notebook right now. And what I'm going to do is I'm going to open this up, and I have a Python notebook here that I've already created called Python intro. And a lot of the code that you're going to see inside of this IPython notebook intro is going to be everything that we've really seen in the session up to this far. We went through an introduction to Python, running different Python, so what is a comment, the syntax for variables that we have. And what I'm going to do is just scroll down, and again, you can interactively open this if you download it onto your system from the course page, and go through a lot of the examples and change the code. But what I want to talk about right now is let's use some of those libraries that we just installed. So I'm going to go down here all the way past the class example and the with example that we had at the very end of the class. We'll go down here to importing libraries. And again, what we just went through is importing NumPy and Matplotlib. So let's go through a little bit of code here. What I'm going to do is import NumPy as np. So whenever I want to call a function from the NumPy class, I can use np. So there's a lot of different functions that are part of NumPy. I'm not going to go over all of them here, but we are going to use a few of them. The first one is the linspace command. And essentially, that's going to create an array of numbers between 0 and 1, and it's going to have 100 different values. So it'll have 100 equally spaced points between the values of 0 and 1. And I'm going to save that as my vector t, right? And it is a vector, right? Because we're using a numeric package. Then I'm going to say np.sign. I want to take the sign of 2 times pi times t. And so y is now going to be equal to 2 pi t. And one of the things we actually could have done here is I could have said, well, let's make this np.pi, I think the main value is. Let's see if this works. And now what I'm going to do is print the maximum value of y and the median value of y. So there's some statistics that are already built into this NumPy package. So let me try and run this. We got an error. So let's see what that error is that we've got. So this is the output. Module has no attribute pi. I must have called it the wrong thing. So let me tab over. Let's see. Do they have? It was pi in lowercase. So I just tabbed over to get this to come up while I'm using my IPython interface. So I'll hit enter. And so now we've got np.pi. So if I look at that, great. The max value that I get back is a little less than 1, almost 1. And the median value, as we expect, is very, very, very close to 0, e to the negative 16th. Great. So now let's import from the Matplotlib library. Now, when I'm moving on, t and y, those are still defined, and I can use those variables in the next block of code inside of my IPython notebook shell. So in this cell, I'm going to, from Matplotlib, import the function pyplot as plt. And so now I can call anything that's part of the pyplot package, the methods, such as plt.plot, and I can plot the value of y versus t. And then I'll do plot.show right here. And essentially, the output of that is going to be a sine wave by running that. Now, if I run that from the cell right now, let's go ahead and do this. It's actually going to bring up this separate figure right here, which is the sine wave from pyplot. And when I close that out, then it'll return back to this. But it doesn't actually include that down here. If I want to include that inside of my Python shell, I'm just going to have to type the percentage sign for an IPython notebook. This tells it I'm about to give it a command. And I'm going to say matplotlib inline. Okay? So what that's telling it is go ahead and print out the figures in line. So I'll do that here, and now it doesn't actually call a separate instance of Python to show the figure. What it's doing is it's going to embed those inside of the HTML. And it really is embedded inside the HTML. It's not a reference to that image. It's actually a PNG that's been base64 encoded inside of the HTML. So I can package this up and send someone the HTML code, and they'll immediately be able to see it and decode it without actually having the image there in the same directory as the HTML. And that's something that's really, really interesting, really great. So the last thing we'll do is I'm going to import SQLite 3. We're not going to do anything with it, but you can imagine that next week you're going to be looking with a lot of how you actually use databases, or later on. So I'm going to import SQLite and just print out the version. And if I do that right here, the version on my system is 2.6.0. And so now, if we have all of this installed, we should be able to do a lot of different things with databases from a Python programming language. So the last thing that we'll talk about is debugging in Python. Debugging is really an art when you get into Python. And what I'm going to do is I'm going to import something called PDB, the Python debugger. So if I import PDB, it gives me access to a couple of different functions, right? So I'll call import PDB up here, and I can call pdb.setTrace. And wherever that function occurs right in here, essentially what's going to happen is it's going to set a breakpoint, and it's going to return commands to the console. So I can step through using different arguments. So if, let's just call this for instance. So I'm going to have a for loop for I in the range of 0 to 5, j plus equals 5 times I, incrementing j by 5 times the value of I. Then I'm going to call pdb.setTrace and return command to the console. So if I do this in IPython, the notebook, when I run this, immediately it's executed into these lines of code, but now I call pdb.setTrace, and it tells me what it just executed above me. Or the next thing it's about to execute. So I called setTrace, so I called the breakpoint right here. The next thing it's about to call is for I in the range of 0 to 5. It's about to increment I inside this for loop. So if I were to say I, hit enter, it prints out the value of I, which is 0. If I were to say j, enter, it prints out we'll do print j. J right here is actually a command called jump that I can do in j. So if I say print j and hit enter, it'll print the value of j right there. So the next thing I can do is say, I actually want to step through this code, right? So I'll say s, enter, and it's stepping through the code. Now the next thing it's about to do is j plus equals 5 times I. So let's do step. It's about to execute setTrace, step, and it'll keep going, and I can step through all of the code. If I want to hit C right here, that's going to be continue. And I'll continue until the next breakpoint. So if I were to print out the value of j right here, it's equal to 5 now. I'll hit continue, 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 and now let's see what the value of j is equal to. It's equal to 50, continue, and now we've actually exited the entire function. So that's one way of actually using debugging straight in the IPython notebook, and you can also do this from the command line, the console, when you run a script. So finally, let's look at one last thing when we're programming with Python. And while it's really wonderful to be able to use the IPython notebook, sometimes we really don't want to use a notebook or HTML to do our code. We want to write scripts, and we want to be very serious about the programming that we're doing. And some of the easiest ways to do that are working with an integrated development environment, or IDE. And Python has plenty of IDEs that exist out there. One that I tend to use is called PyCharm. And so what we're going to do now is actually open PyCharm and just look at some of the few capabilities that are there. You're welcome to explore it on your own or use it for when you're completing your homework. And I encourage you to get familiar with at least one IDE that allows you to set breakpoints and step through code as you would normally do when working with other programming languages that have those dedicated IDEs. So right now I have open the IPython notebook that we used before. And what I'm going to do is just copy over this code that we used PDB before on. And I'm going to create a new project in PyCharm that runs this code, and we're going to set breakpoints. So first of all, let me open up PyCharm. So go ahead and install PyCharm or whatever IDE you find on the internet that you use or have liked to use in the past, and try to run some of this code and debug with me. So in PyCharm, the way that I'm going to do it is I'm going to create a new project. And the project name that I'll give it is going to be, let's just call it charm underscore intro, right there. And I'll hit OK. So it'll create a new folder inside one of my directories. In this case, it's in my Dropbox and resources. And it's going to be called charm underscore intro. Now, the next thing I can do that I need to do is going to be add some files to this directory. So what I'll do is I'll create a new Python file. And we'll call that Python file intro main. You can call it whatever you'd like. Okay. And it's automatically going to insert this variable author. And these underscores means that it's supposed to be private, although nothing is really private in Python, but at least lets the whoever's using this API know that this is supposed to be a private variable. It should be treated as such. So the first thing I'll do is just copy over what we had before. But now I'm going to take out this PDB stuff because I want to use the IDE itself to set and run breakpoints. So first thing I'll do is just run this without setting any breakpoints. So if I go to run, what I'm going to do is intro.main. We'll run intro main. And we'll have this go right here. And bam, it connected to the debugger. And the output that we have printing of J is 50. So now what I can do is run this in debug mode. And the first thing I'll do, click here and set a breakpoint right here. So now when I run this, hit Command R. So I'm going to run intro.main. And now I'm actually stopped in the debugger right here. And this is the console. So there's all sorts of variables that are on the watch list right here. So I can see the author variable is EC Larson. There's also some other private variables that I haven't seen in Python yet, or that we haven't seen, that have come in. So I can also see that int I is equal to 0, and j int I is also equal to 0 down here when I'm looking at my watch list. Right? So this is a really, really great way of looking at some of the code. And now what I can do is step through it. So I can step over this code and step through. And at each time it'll give me a new update of what the variable's watch list looks like. So now j is equal to 5, j is equal to 15, and I is equal to 2. And I can also just say keep going in this program and execute all of the way through. We'll resume the program. And again, it gets back down to the breakpoint, so I can remove this breakpoint if I want to, and then tell it to go all the way down. And if I look at the console output, it has in seed given 50. Great. So that's how you use PyCharm, and should be able to enter all of the code that you want here and step through this IDE using a lot of the things that are probably familiar with working with other code IDEs in the past.